Welcome to Green Designs, I'm Nat Holloway.
And I'm Dan Hayworth.
As project managers for sustainable buildings, we are always asked what's the best way to make your house more environmentally friendly?
Of course, there's never one single answer to this question. So each week, we're going to be looking at different ways to achieve the same end, whether it's building, heating or lighting your home.
This week, we've been asked by a client whether it's best to build with a steel frame or a wooden frame. We're going to talk to an expert, see houses designed with each, and see how they weigh up.
Okay, I'm off to see a modular wooden house in Muriwai.
And I'm off to talk to an expert.
In our search for an interesting use of timber, I've come here to Muriwai on Auckland's wild west coast to look at an intriguing house that redefines the way homes are designed and built. Created by architect Tim Dorrington for Rhys Owen and his wife, it is a project inspired from 1940s American architecture, using modern materials and a new build process to create a modern, greener home. The house is built using a structure of engineered timber beams, with sandwich panel walls providing a sturdy, environmentally friendly and flexible design. Inside, the use of heating methods such as solar heating, double glazing and the wood burner add to the efficiency of this startling new build. The site itself is nestled on the side of a hill among native trees and bush, and it's here that we find this rather unusual angular house. So Tim, this is a really unique house you've designed here. Tell me a little bit about the design concept.
So this is it's a modular housing structure that we've been working on for the last couple of years. This house here is a medium and a large module put together to make a three-bedroom house. This one and this one put together like this.
So this is the house that we're standing in now?
Yes, this is the house that we're in right now, yes.
It's a very linear and precise building. Was it hard to build?
It had its challenges. It certainly had its challenges, being a prototype of the system that we've been working on. There were definitely some unknowns that we couldn't really answer until we got on site and actually tried to build it as a one-on-one model. As I'm sure Rhys can testify.
So it was a bit of a challenge, was there, Rhys?
There was. I can see it being a challenge, being the prototype, and there's always going to be those prototyping issues. But I think, as you can see, pretty much everything's been resolved.
Yeah, we were really lucky with Rhys and Joe, and that they totally bought into the system and the idea that this was the prototype and stuff. So it's been a learning experience for us all, really.
So these laminated veneer lumbers, these beams and the posts, are they something that you are using more of in your designs?
Yeah, we are. There's a couple of materials you can make beams out of, and this seems to tick a lot of boxes. It's timber. It's it's a good product to use, and it can span quite far. Not quite as far as steel, but quite far.
Yeah.
Without being too chunky.
As you said, it's architecturally intricate, but it's very clean and straight and simple looking as well, which is what we were after. We didn't want lots of fiddly bits here and there, and I think it's exactly what it's actually beyond what I ever expected to live in.
Oh, that's good to hear.
That's great.
Yeah, it's definitely a step up.
Yeah,
it's awesome.
Another important feature of this house is the solar water heating. Tim talked me through how this works. So this system is the heart of the hot water system for the house.
Yes.
How does it work?
Well, this is a solar hot water system. So what we've got is we've got some solar panels on the roof which heat up with the solar energy. As the water heats up to a certain degree, it cycles down to this, which is the storage device for the system. And the water sort of transfers between the two to maintain the temperature down in the tank here.
And this provides enough hot water for the whole family all year round?
Yes, it does. Yes, this is the only device we have in the house.
It's a pretty amazing bit of kit.
Yeah, thank you.
I'm at Macintosh Timber Laminates, where the glulam beams for the box house came from. We're going to go inside shortly, talk to Owen and find out how they're made. Hi there, Owen. Good, thanks for having us in.
Welcome.
We've just finished building the box house in Muriwai, where for the exterior structure, for the exterior beams and posts, we used all glulam materials. And I'm wondering if you could talk us through the process as to how a glulam beam is made.
Yep, sure. We use radiata pine material, and we get that in the factory already kiln dried and treated. First thing we've got to do is make sure it's up to grade, remove out of grade knots, and then finger joint the in-grade pieces together to make the long lengths, whether they're 10, 20, 30 metres long. Once they're finger jointed and they're cured, it's got to be plain so that we've got clean thickness surfaces.
Right.
We then glue them into their presses, and for that we've got to make sure we get right glue mixes, temperature control, humidity, and the right pressure on, so we torque the pressures at the beams up to the right pressure. They're left there to cure, and then once they're cured, the next stage is the machining. So they'll go through a big beam planer, which can take beams 2 metres wide, 300 deep, and then we're into the finishing stage, either sanding, polishing, and they're ready to go out to site.
Right. And the glues must be very, very special to work in the exterior conditions and to hold such a complex thing together.
Yes, the glue we use for that type of work is the resorcinol, and that was developed during the Second World War for the PT boats so that they wouldn't be located by the radar. So it's well tested in either heat or water. The glue won't break down.
One of the reasons for choosing glulam beams at the box house was that it was a sustainable material, and I'm just wondering if you could explain how glulam stacks up environmentally.
Well, good question, because in New Zealand we have a great resource of 1.8 million hectares of plantation radiata pine. And then in terms of embodied energy, to actually produce a timber beam compared to a steel beam, the steel beam will take 14 times more energy for its production than the timber will. So we've got a plus there. Right. And then you've got your carbon situation. With that beam will store up to 16.2 kilograms of carbon. The equivalent steel will actually emit 28 kilograms of carbon.
Right.
So whether it's sustainability or energy or carbon, timber is the way to go.
We've seen from the box house in Muriwai the post and beams are made of glulam.
Yeah.
What other applications are there?
Oh yes, there are a lot, and we've been involved in things like bridges, motorway bridges over 61 metre spans, sports stadiums, gymnasiums, churches, halls, resorts, restaurants. In fact, we recently did the Treehouse restaurant. So
yes.
Any type of commercial work, and very often the structural member becomes the architectural feature as well.
Right, well, like it has for the box house.
It has indeed, yeah.
Thank you very much for showing us around the factory.
It's been a pleasure to have you, and I hope it's been useful for you.
Very much.
Great,
Thanks.
Thank you.